Hey class, today we're going to start 8.2. Yes, we're going to do 8.2 before 8.1. When we get to 8.1, it'll make a little bit more sense on geometric mean. So 8.2 is Pythagorean theorem and its converse. So our objectives, so by the end of today, these are the things that we want to be able to do. Use Pythagorean theorem. We've already learned this, so it should be pretty easy to have that check mark. And then to use the converse of the Pythagorean theorem. So we're going to find out what the converse is and what it means in a little bit. But those are the two things that when we're done watching the video, you should be able to say, yeah, I can totally do that. So let's get right into it and start off with Pythagorean theorem. This, you guys remember, Pythagorean theorem, if the triangle is a right triangle, then we know that a squared plus b squared equals c squared. So here, using Pythagorean theorem is when we know it's a right triangle, but we're missing one of those sides, a, b, or maybe that hypotenuse, c. Remember, a and b stand for the legs, and c is our hypotenuse. Remember that hypotenuse is going to be our longest side. And it also is going to be across from that 90-degree angle. So if we look here in our example next to it, we see our 90-degree angle and we go across, and so that C is our hypotenuse, the longest side in this triangle. Let's go ahead and put this to work. If we start off with our first problem here, we see we have a side that has 6 and 15. Those two end up being our legs because the x is directly across from that 90-degree angle. So that's what it's squared from. Caution, one of the most common mistakes I see from students is they go, oh, there's the variable. That must be the hypotenuse. No, 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 no. Start off by looking for that right angle. Across from it, that's where you're going to find that hypotenuse. Then we're going to square the legs. And it doesn't matter what order you're going to put that the legs in. You could do 6 squared plus 15 squared, or you could flip it. It's the same thing as saying 2 plus 3. It's the same is going to be the same as 3 plus 2. All right, go ahead. Pause the video if you need to be able to type those into your calculator. I'll give you a second here. All right, add those two up together. And what you get for your total ends up being equal to x squared, which is our 261. Now, we want x by itself, not x squared. So think about opposite of squaring something. Yeah, it's square rooting it. The square root of 261, we're going to just round that to one decimal place and get 16.2. All right, let's take a look here at our example 2. I find that right angle, and I see across from it is that variable. And that's what I'm setting it equals to squared. That's my hypotenuse. We're going to take our legs and square both of those. Go ahead and square both of those and add them together to tell us what is our x squared equals to. If you got 338, that's correct. Good job. All right, remember we want x by itself, so take that square root. And x ends up equaling 18.4 when we round to one decimal place. Just a reminder, if we're going a little too fast for you, feel free to pause the video so you can write, rewind it, rewatch something. If you still don't get something at that time, write me a note on the side of your notes sheet, and then we can talk about it when we come to class tomorrow. All right, example 3, I'm just going to get it set up with you. Find that right angle, and across from it is 11, so we're going to square that. Doesn't matter the order of the legs. So this one looks a little bit different than the last two we set up, but I'm confident that you guys are going to be able to get that answer. Go ahead and do that for me for tomorrow. Next thing we see here, it says common Pythagorean triples. What a Pythagorean triple is 3 numbers that will always work out to give us a perfect right triangle Pythagorean theorem. Whole numbers, really nice to work with. If we look here at our first example, 3, 4, and 5, if we take 3 squared and we add it to 4 squared, that should equal, oops, I almost started to give away the answer, 5 squared. So let's go right up here. 3 squared is 9 plus 16, which is our 4 squared. And our 5 squared is 25. If we add that 9 and 16, go ahead and add that. Did you get 25? I got 25. See how that ended up working out real nice? So that's a thing that if you see that it's a right triangle and you know the two legs are 3 and 4, automatically you can say, oh, I know my hypotenuse, that's going to be 5. Or maybe you know the hypotenuse is 5 and one of the legs is 3. You're going to recognize that as a common Pythagorean triple, so that missing leg is going to be 4. What else we can see here, we got some other boxes here, is if I make this 6, 8, and 10, I'm going to ask you, what did I do to each of those numbers in my original Pythagorean triple? Yeah, I times those by 2. And that gave me a new Pythagorean triple. If we go ahead and squared 6, 8, and 10, 6 squared plus 8 squared is going to equal that 10 squared. We could also do that with 9, 12, and 15. So what we did here was we took our original numbers and we times them by 3. So what we're saying is we could take our Pythagorean triple, and as long as we times all 3 of them by the same number, it's going to be a nice common Pythagorean triple. All right, so let's look. I'm just going to get you started on filling in this next part. So again, let's take our next Pythagorean triple and times each of them by 2. And 10, 24, and 26 are going to be a great Pythagorean triple. I want you guys to go ahead and finish filling out this chart. So in our middle column, take the original Pythagorean triple, times it by 3, then try it by x, and do that with the last column. All right, let's go to the back side of our notes and check this out. Here's where we're going to start with the converse of the Pythagorean theorem. Remember back at the beginning, Pythagorean theorem, said that we know it's a right triangle, so we know those sides squared equals the hypotenuse squared. Here, the converse is going to go the other way. We know that the side squared equals the hypotenuse squared, so that's going to give us a right triangle. All right, and then here's our inequality theorems. I'm just going to flip these around. If you read it, if c squared is less than a squared plus b squared, let's flip that around because more often you're going to see it this way. A squared plus b squared is greater than c squared. So c squared is small. So think about our triangles. What's a small triangle? Another name we could name a small triangle? Well, that's going to be an acute triangle. Acute angles are small, and in this inequality, the c squared is small, or hypotenuse squared is small. All right, then we can also adapt that here. Again, I'm just going to rewrite the order. This time, our sides, the sum of our sides squared is going to be less than c squared. So c squared this time is big. Well, what's another name for a big triangle? That's going to be our obtuse. Oh, spelling. Ooh. Obtuse. There we go. Obtuse triangle. You guys don't have those drawings in your note sheet, so go ahead and add those into your note sheets. All right, let's look here. Number 5 says, determine whether each set of numbers can be the measures of the sides of a triangle. If so, classify the triangle as acute, right, or obtuse. So the first thing I read when I read the directions is first we needed to determine if it can even be a triangle. Think back here. We learned this last trimester or the previous trimester about how to figure out if it's a triangle. If the sum of the two smaller sides is greater than the largest, then yes, it's a triangle. So if we look here, 7 and 14 were my smallest ones. So we add them together and we get 21. Is 21 greater than 16? Why, yes, it is. So yes, we know it's a triangle. We need to decide what type of triangle now. So we're going to set it up using the converse. So take the legs, and I know 7 and 14 are my legs because 16 is my largest length. So that's my longest length, so it's a hypotenuse. We want to know, is it equal? Go ahead, pause the video, come back, see what 7 squared and 14 squared is. All right, 7 squared is our 49. 14 squared is our 196. we want to know, is that equal to 16 squared, which we have is 256. Go ahead and add the 49 and the 196. And we have 256 over here. We want to know, is that equal? Is that going to be less than or greater than? We get 245, and 245 is going to be less than 256. So here we're thinking about it. My hypotenuse is big. The triangle that's big is going to be that obtuse triangle. So we have an obtuse triangle here with problem 5A. Go ahead, let's look at B. We'll just get this one started. Let's first just decide together, is it even a triangle? My two smaller sides are 9 and 40. We want to know, is it greater than 41? Well, yes, 49 is greater than 41. So yes, we know that this is a triangle. I'll get this next part set up with you, and then you're going to determine what type of triangle it is. Remember, take our legs, our small portions, square them, and see if they are as big as our hypotenuse squared. Then you have C all on your own. All right, 6 gets us started out here. It says find x. Well, I can see here, there's an x, and there's an x. But we want to solve for that x. Let's get the problem set up. You guys can try it out for tomorrow. So my right angle, boom, right here. Right across from it is my hypotenuse. So that's x squared. My two legs, 8 squared plus x minus 5 squared. Now, the big thing I want to point out here is right here. X minus 5 squared. So we're taking a binomial squared. We don't just distribute that squared, because remember, squared means times by itself. So we do x minus 5 times x minus 5. Foil that and plug it back in to the problem. You'll be able to give us x. And here's the last one, 7. Find the perimeter and area of the figure below. Notice we're missing this one side right here. And here's our right angle. So go ahead and do Pythagorean theorem. You're going to find us that angle, or excuse me, not that angle, that side. And that's going to be able to give us the perimeter, and you're going to be able to find area. All right, guys, so finish those few things up, and we'll see you tomorrow to finish the notes in class.